The topic of this lecture will be what makes a good leaving group. The leaving group of a substrate for a nucleophilic substitution reaction is important for two purposes. First, it polarizes the bond to the carbon that acts as the electrophile, and that makes the carbon a better electrophile. Second, it is a species that can leave with an extra set of electrons, the bonding electrons to the carbon. Therefore, there are several traits that make something a good leaving group. First, it needs to be electron withdrawing. If the leaving group is very electronegative, it allows the leaving group to polarize the bond to carbon. For example, halogens make good leaving groups. Because the halogen is more electronegative than carbon, it polarizes the bond and pulls electrons towards the halogen, making the carbon more electropositive. This makes the carbon a better electrophile. Other atoms that make good leaving groups due to their ability to polarize the bond to carbon are oxygen, nitrogen, and sulfur. Another feature of an atom or group that acts as a leaving group is that it must be stable once it has with those additional bonding electrons. Something that is stable with extra electrons is a weak base. Remember that we discussed a similar thing when we talked about the strength of Bronsted-Lowry bases. Therefore, weak bases make good leaving groups, and strong bases make bad leaving groups. Let's look at some examples of good leaving groups. Ions that make good leaving groups are the conjugate bases of strong acids, including chloride ion, bromide ion, and iodide. Also phosphates, sulfonates, and sulfates. Take a moment to think about why these last three are very good leaving groups and why they're so stable. The answer is, of course, resonance. These ions are resonance stabilized, allowing the molecules to spread out the negative charge, making them more stable and happy with those extra electrons. Neutral molecules make good leaving groups as well because they don't have a charge to stabilize once they've left. So if you can make your leaving group become a neutral molecule once it has left, it will be a better leaving group. Neutral molecules that make good leaving groups include water, alcohols, amines, thioethers, and phosphines. Remember that a leaving group that is neutral while still bound to its substrate will become anionic upon leaving, while a leaving group that is positively charged while still bonded to its substrate will be neutral upon leaving. The final aspect of a molecule or atom that makes it a good leaving is it being polarizable. There are a couple ways to think about this. Remember that a polarizable atom is very large and squishy. What that means is the electrons move around a lot. This can be good because it helps to stabilize the extra electrons because they can move around more. More importantly, though, a polarizable leaving group allows more overlap of the orbitals in the transition state. Remember that the transition state is the highest energy point as the reaction proceeds. The energy of the transition state is the activation energy, which is directly related to the speed of the reaction. If we lower the energy of the transition state by increasing the orbital overlap, the reaction will proceed more quickly.